of want to talk about a problem like this where you have a projectile and it's on a long level range. This is perfectly flat, so the initial position and the final position are the same. That allows us to say that delta y is 0. That's a really important observation to make. On a horizontally fired projectile, that's not true. The initial position and the final position are different, and VOY is 0, and that whole middle term goes away. But on this one, delta y is 0. We can solve this for time. We can see that this, one of these times over here, the time on the left goes away. I get this expression, negative 2 VOY over A. I plug some numbers in, and I get about 4.7 seconds. That VOY is not the 28 meters per second. That's not at all how fast I was going. We had to first resolve that into its x and y components, and that's where I get 15.7 and 23.2 meters per second after applying some of those trigonometric vector resolution rules that we learned on Monday's class. Are there any questions on how we resolved the vector or found the total time of flight? Okay, that only gets us to here. That's how much time it took for it to go from beginning to end. How much time is it going to take us to get to this maximum height position? Half that time. There's symmetry here. If we're ignoring air resistance and other effects, this is just a perfect parabola, and we can say that this is the total time divided by 2 at the top. So now we have this additional piece of information where we know how much time it took to get to the very top of its trajectory, and we can do additional analysis in the y direction to figure out how high it is at that point. I'm going to give you guys another minute or two to figure that out.